semester we've been using acids and bases. We've learned how to name them and write formulas for them. We've performed reactions with them, but in this topic we're going to specifically talk about properties of acids and bases and pH. So some properties of acids are that they taste sour. They conduct electricity. Remember, electricity is the movement of charged particles. So in this case, we're going to ionize acids, and those charged ions are going to move from one place to another, which allows them to conduct electricity. They change the color of specific indicators, and we'll talk in later video about different types of indicators. One example that you might have used is litmus paper. So blue litmus paper turns red in the presence of an acid. They have a pH less than 7. And if we're looking at a chemical formula, we can identify that is an acid, and we should know that that's because it would start with hydrogen. And some examples of acids is HCl. So remember, if there is hydrogen with just an element, we use the hydro prefix, so that's why this is hydrochloric acid. Whereas this is hydrogen with sulfate, which is a polyatomic, so we just say sulfuric acid. This is nitric acid. So anything that starts with an H is considered an acid. However, the exception to the rule is water. Water starts with hydrogen, but it is not an acid. Now, there's lots of different chemical reactions that we have already observed acids reacting. So acids can react with active metals. And one of the examples that we have seen is mixing aluminum with hydrochloric acid. So we put aluminum with HCl, and we tested for hydrogen gas, and we performed the splint test, and you heard the pop. The other product is a salt. So in this type of reaction, you have an individual element, a metal, reacting with a compound, an acid. So this type of reaction is considered a single replacement. So if we look at the chemical equation for another example of an acid reacting with a metal, we have hydrochloric acid here reacting with magnesium. So magnesium is going to kick hydrogen out of the compound because it's higher on the activity series than hydrogen. So hydrogen is left alone, and magnesium chloride is the other salt. And again, we tested for this by using the splint test. So this is an example of the skeleton equation for hydrochloric acid with magnesium. Now, acids also react with carbonates and bicarbonates. So you're very familiar if you mix vinegar and baking soda that we have a reaction. Well, vinegar is an acid and baking soda is a bicarbonate. Okay? Here's another example. So we have hydrochloric acid with sodium bicarbonate, which is baking soda. And in this case, we end up with 3 different products because we have a double replacement and then a decomposition. So we end up with a salt, water, and carbon dioxide. So the salt is sodium chloride, and then here we have water and CO2. Now, because acids can react with carbonates, we see effects of acid rain on marble statues and structures over time. So marble is made up of calcium carbonate, and rain can be slightly acidic. And so over time, you can see this is an aged photograph of a statue of George Washington. So you can see that the acid rain is eating away at the marble. Now, we also learned about a special case of a double replacement where acids neutralize bases. So in this case, we mix an acid and a base together, and we don't use the solubility rules because this was a special type of reaction where this always happens. And the sodium will go with the chlorine, and the hydrogen goes with the hydroxide. So we end up with sodium chloride and water. So we end up with a salt and water when we neutralize using acids and bases. Now, I mentioned that hydrochloric acid has a pH less than 7. Well, sodium hydroxide has a pH higher than 7. And so when you mix them together in the correct proportions, then we end up with this ionic compound salt and water, which is neutral, which is why at the end your products are neutral. This only works if you use exactly the right proportions or the stoichiometric amount of the acid and the base. I'm going to talk a little bit about a few different acids and what they are used for practically sort of in industry. So we've used sulfuric acid in the lab. Sulfuric acid is the highest produced chemical in the United United States, and it's used for the production of paper and fertilizers. It's also found in batteries. It's what battery acid is. So if you ever drive down I-40 past Canton, you know that it kind of smells bad, and that's because of the sulfur sort of byproduct that's happening from using the sulfuric acid in the paper mill in Canton. So nitric acid we've used in the lab a lot, and it has it's used for producing fertilizers as well. It can be used in building explosive. It's extremely volatile acid, and it actually can stain proteins. So if you ever get it on your skin is full of proteins, and it will leave like a little yellow spot on your skin. Hydrochloric acid is used for curing or pickling steel. It can be used to purify or pull magnesium out of seawater. It's also the acid that makes up your gastric juices or your stomach acid, and it helps to digest proteins. If you were to go to a hardware store and buy it, it's called muriatic acid, and it's used for etching concrete and for masonry work and things, before you like paint your garage floor or something like that. Phosphoric acid we rarely ever use in the lab. It's in small amounts can be used as a flavoring agent. It makes sodas tart. It can be a detergent. Also, again, it's used in fertilizers. Phosphorus, nitrogen, these are important nutrients for plants, so that's why it's used as in fertilizers. But again, we don't commonly use this in the laboratory. Acetic acid is used, when it's concentrated, it's used to manufacture plastics and in making pharmaceuticals, but more often you see it in your home. Diluted acetic acid is actually vinegar. Alright, so let's talk a little bit about bases. So bases are a metallic hydroxide, so it's a metal with an OH. And again, they react with acids to form water and a salt. Acids taste sour, and bases are bitter. They're slippery to the touch. If you ever get sodium hydroxide on your hand, even like the very low concentrations, and you're washing it off in the sink, you can feel that it's slippery. They can also be electrolytes or conduct electricity, so they're used in batteries as well. And they change the color of indicators. Red litmus paper turns blue, and we'll talk about other indicators that we use for looking at acids and bases. So some common bases are sodium hydroxide. Sodium hydroxide is used for drain cleaner and making soap. Potassium hydroxide is the base that is used in alkaline batteries. So typically when we think of batteries, we think of battery acid. Well, battery acid is that sulfuric acid, but we also have the alkaline batteries, which contain potassium hydroxide. Magnesium hydroxide is milk of magnesia, so it's used when you to settle a sour stomach, right? So in your stomach you have hydrochloric acid, so if you take magnesium hydroxide, it helps to neutralize the acid in your stomach. And then also calcium hydroxide, which is lime, and is used for masonry work and things like that. Alright, in the next video I will talk about really what defines and what makes something an acid or a base, and the different theories of acids and bases.